Dear students, welcome to our YouTube channel PCM Academy. Let us continue our discussion on problems and solution of H.C.Verma volume 1. Okay, so we'll continue from question number 11. So if you want to see all the videos of solution of this book, then you can go to the playlist. There is different playlist. One playlist is there, that is for H.C.Verma Solution. So this is chapter number 5. Okay, so the first question is that a small block B is placed on another block A, as you see from this figure, of mass 5 kg. That means the mass of A is 5 kg. Okay, a small block B is placed on another block A of mass 5 kg. That means the mass of this A is 5 kg. 5 kg. And length 20 centimeter. So this length is just 20 centimeter. That means 0.2 meter. Just 2.2 meter. Initially the block is near the right end of a block A, that you can see from the figure. A constant horizontal force 10 Newton is applied to the block A. All the surfaces are assumed frictionless. Find the time elapsed before the block B separates from A. So here, as the surface is frictionless, so there will be no force exerted by A on B. So B will be at rest at its position and A will move. So when A will move, the distance 0.2 meter, so B will separate from A. The acceleration of A, if you talk about what is the acceleration of A, that means the force divided by mass. Here force is 10 Newton and the mass is 5 kg. That is just 2 meter per second square. So now how much time it will take to cover the 0.2 meter will be the time elapsed before the block B separates from A. Okay, so you know from your kinematics equation that S is equal to just half at square, because initial velocity is 0, so it is just half at square. So T will be root over twice S upon A. So it will be just twice S upon A. So that is root over 2 into 0.2 divided by 2. Okay, so this will be just, so that will be 0.2 root 0.2, that means under root of 2 by 1 by 5, and that will be equal to, calculate this, you will get just 0.45 second. Okay, so this is how you can solve this question. Now let me move to the next question. This is the question number 12. Here you can see man has fallen into a ditch of width D. Okay, so ditch of width D, and two of his friends are slowly pulling him out using a light rope and two fixed pulleys as shown in figure, so that the force assumed equal for both the friends exerted by each friend on the rope increases as the man moves up. And the force, first what you have to find out, you have to show that the force exerted by each friend on the rope increases as the man moves up, and then you have to find the force when the man is at a depth H. Okay, so what is the force that acting by these two friends is just tensional force along this direction. So here is also tensional force and here is also tensional force. Okay, now what will be the net force that is acting vertically along this direction? Okay, so if this angle is theta, suppose let us take this angle is theta, so this angle will also be theta. Okay, so the force that will be acting along this direction, that will be 2t cos theta. So the force acting will be 2t cos theta along this direction. Okay, but this is H actually at a depth H, so this is H, and this is the halfway, so this is 2 g by 2. Now the mass of the man is M, then the force acting downwards will be just mg. That means if you draw the free wheel diagram of the man, so that will be along this direction, this is mg, and along this direction it will be 2t cos theta. 2t cos theta. Okay, so that the force, so you can see as soon as the man will be moving upwards, so here let us suppose that there is no acceleration. Okay, so what will happen, this 2t cos theta will be mg at any position. At any position, that will be 2t cos theta is equal to mg, is equal to mg. Now what is t? Okay, what is t? So what t is the force actually, and you have to show that the force exerted by each friend on the rope increases as the man moves up. So you have to find out that H is decreases, then t will be increased. So how it find, so you can find out from here that the 2t cos theta just t is equal to, just you can find out from here mg upon 2 cos theta. Let us find what is cos theta actually. What is cos theta? You can see from here, just from this equation you can show this. Let us first find out just the first question, that so that the force exerted by each parent on the rope increase. So you can see from this equation that when the man moves up, theta will increase here. As soon as the man moves up, your theta will increase. So when theta will increase, what will happen? That means the cos theta will decrease, and as soon as cos theta will decrease, the t will increase. T will increase. So you can say that the force exerted by each friend on the rope increases. So T will increase means force will increase when cos theta will decrease. When cos theta will decrease, when theta will increase, and when theta will increase, then H will decrease. So if H decrease, that means the man moves up. So when H decrease, cos theta decrease, cos theta theta increase, so cos theta decrease, so T will increase. That means when the man moves up, the tension force T will increase. So that is what you have to show here. But the second question you can see, find the force when the man is at a depth h. So you have to find out t in terms of h. So you have to substitute cos theta. So what will be cos theta? If you see this triangle, you can see. So this is your hypotenuse, and hypotenuse will be just h square root of just h square plus d by 2 whole square. So this is your hypotenuse. So what will be cos theta? Cos theta is nothing but base divided by hypotenuse. So base is here h, and hypotenuse is just root over h square upon h square plus d by 2 whole square. So it will be just in this way you can write. So 2h divided by 4h square plus d square. 4h square plus d square under root. Now if you substitute here cos theta, then what will happen? So t will be just mg upon 2 into 1 by cos theta means root over 4h square plus d square divided by base of h. That means mg upon 4h. Okay, yes. So it will be just mg upon 4h under root 4h square plus d square. So this is the final answer. This is the magnitude of force actually. Okay, so let's move to the next question. Question number 13. So the elevator shown in figure is descending with an acceleration of 2 meters per second. The mass of the block is 0.5 kg. Block A. What force is exerted by the block A on block B? So if the force exerted by block A on B is R, then R will react with the same force. B will be react with the same force R. So if you draw the free body diagram of A, so what is the free body diagram of A? The mass mg will be acting downward, and a force R will be acting upwards on M. And we have to find out R actually. So R is the force given by B to A and A to B, and here the acceleration is along downward direction, 2 meters per second square. This is the acceleration. Now if you write the equation of motion, this will be just mg minus R is equal to ma. Okay, so what will be your R? R will be just mg minus ma. That will be m into g minus a. Now what is a? M is 0.5 kg. What is g? G we can take at 9.8 minus 2. So that means 0.5 into 7.8. So this is your answer, I think. Yes. So this will be just 3.9 Newton. That will be almost equal to 4 Newton. Okay, so this is how you can solve this problem. Now let's move to next question. That is question number 14. So pendulum bob of mass 50 gram is suspended from the ceiling of an elevator. Find the tension in the string if the elevator goes up with acceleration 1.2 meters per second, goes up with the deceleration 1.2 meters per second, goes up with uniform velocity, goes down with acceleration 1.2, and goes down with deceleration this, and goes down with uniform velocity. So several cases are there. So let us first draw the diagram. So here mass of the pendulum is just 50 gram. That means just 0.05 kg. Okay, we have to find out first this. Now what is the scenario here? Suppose this is our left A pendulum suspended from ceiling by an elevator, so it's suspended like this. The tensional force is there, and mg along downward direction. Okay, so tension, we have to find the tension in different cases. So for case 1 or case A, you can say goes up with an acceleration a. So it will goes up with an acceleration a. So what will be equation of motion? T minus mg is equal to m. So it will be just T minus mg equal to ma. That means T is equal to just mg plus m. mg plus ma. That means m into g plus a. So what is m? M is 0.05. What is g? G we can take 9.8 plus 1.2. That means 11. 0.05 into 11.2. G is, you can take 10 or 9.8. So if you take 9.8 or you can take 10 also, I think answer will be match if you take 10 here. So that's what whatever you can take. So let me take 10 also. 11.2, and that will be give you the answer 0.56 Newton. Okay, so this is how you can solve. But for part B, goes up with the deceleration. So deceleration means A will be negative. So for case B, you should write here T minus mg is equal to minus ma. So that will be T is equal to mg minus ma. That means m into g minus a. Okay, and that will be just 0.05 into 10 minus 1.2, and that will give you the result 0.4. Okay, then C goes up with uniform velocity. So when uniform velocity, so acceleration will be 0. So for part C, you can see as acceleration is 0, so T will be just equal to mg. Simple. Okay, so that means 5 Newton. 0.05 into 10, that is 0.5 Newton. 0.05 into 10 just, that means simple 5 Newton. 0.5 Newton. Now part D goes down with acceleration. So if it is goes down with acceleration, that is same as goes up with the deceleration. So it will be same as B, case B. And goes down with deceleration will be same as goes up with acceleration. So it will be same as option A. And goes down with uniform velocity, again acceleration is 0. That means C will be this. It will be mg just. So you don't need to solve all this because some are same thing. Okay, so moving up with acceleration is same as moving down with deceleration. Okay, so you can solve this question in this way. Okay, so now let me move next question, that is question number 15 actually. A person standing on a weighing machine placed on the floor of an elevator. Okay, so weighing machine is placed on the floor of elevator and a person is sitting there, the elevator. Okay, suppose here the elevator starts going up with some acceleration a, suppose, moves with a uniform velocity for a while and finally deaccelerate to stop. So first it will be accelerated, then uniform velocity, then deaccelerated to stop. The maximum and minimum weights. So maximum weight is 72 kg. So what will when that will happening? So when the move will be accelerated upwards, in that case the weighing machine give you the force N is equal to mg plus ma. Mg plus ma, because in that case, you know, for mg will be in downward direction and n will be in upward direction. So you can write the equation of motion something like n minus mg is equal to ma. N minus mg is equal to ma, and which will give you n is equal to mg plus ma, and that means that g plus a equal to n by m, and n is maximum here, so it will be 72 by m. But otherwise, when it will be deaccelerated, in that case that will be mg n minus mg is equal to minus ma in that case. So when it will deaccelerated, when deaccelerated, then n minus mg is equal to minus m. That is n is equal to mg minus m. Mg minus m. That means m into g minus a. and that will be minimum. That means that will be just a 60. So g minus a will be 60 upon m. So you have two equations, you can see. One is g plus a equal to 72 by m, and another is g minus a, that is equal to 60 by m. Now you have to solve this two equation, and if you solve this two equation, then you will get a just simply. So by solving 1 and 2, you will get a, and that I am going to give you the result. You should solve this two equation, and you will get just a is equal to g upon 11, and here g is 9.9, so you can write that 9.9 by 11, that will be just 0.9 meter per second square. This is your acceleration. Okay, so if you when you get the acceleration, then what you will get, what you have to find out, assuming that the magnitude of the acceleration and deceleration are the same, okay, and that I have used also a, the true weight of the person and the magnitude of the acceleration. So acceleration we have got that 0.9, and what is the magnitude of the what is the true weight? True weight is just mg. True weight is just mg. Okay, so w is equal to mg, just true weight mg. And what is m? So you can find out m from this two equations also. You will get a, and at the same time you will get m, and if you solve here from here, you will get m is 6.66 kg. Okay, so from these two equation solve, and you will get just a and m, obviously. So a will be g upon 11 and m will be 6.66 kg. Okay, so what will be your weight? Weight will be mg, and that will be m is what? 6.66, and you can take g as 9.9, and almost equal to 10. Okay, so that will be almost equal to 66 kilogram. 66 kilogram. So this is how you can solve these kinds of problems. Okay, so in the next class we will discuss some more problems. For today, thank you.